So after we found the full perpendicular from a point to a line, we're going to proceed on to find the shortest distance from the point to a line. So over here, we're going to use the same point and same line as the previous portion of this question, where we actually try to find the full perpendicular. Okay, so using the same point, which is 224, and the line minus 112 plus lambda 122, we're going to learn how to find the shortest distance from a point to a line. So if I can quickly draw out, here's my line, r equal to a plus lambda d. Essentially, to find the shortest distance from a point to a line is essentially something like finding the foot of perpendicular as well. Okay, you can quickly derive that the shortest distance from a point to a line is also equivalent to me finding modulus of PF. Okay, so assuming we actually found the foot of perpendicular already, we can find the shortest distance from a point to a line using modulus of PF very quickly. Okay, but we have two methods to learn here. Okay, first method, which I have just quickly mentioned over here. Method 1, which is using the foot of perpendicular. Okay, from the previous part, we learned that OF is equal to 0, 3, and 4. So quickly find the PF. Essentially is equal to 0, 3, 4, which is OF, minus OP, which is 2, 2, and 4, which will give me minus 2, 1, and 0. Okay, and finding the modulus of PF is equivalent to square root minus 2 square plus 1 square, which will give me square root 5. Okay, so root 5 will be the shortest distance from a point to a line. The point which is 224 and the line which is minus 112 and plus lambda 122. Of course, this is very easy if you have found your full perpendicular. Okay, however, questions out there during your prelims, during your A-levels, during your exams, we can actually ask you to find the shortest distance from a point to a line and give you only 2 marks without asking you to find a full perpendicular. So it doesn't make sense for you to find a full perpendicular because you're going to waste a lot of precious time trying to find a full perpendicular. Okay, so you're going to learn the second method, which is related to the vector triangle that I did mention in vector 1. So if you see through my lessons in vector 1 or you have went through the lesson with me in vector 1, you should recall very clearly about the vector triangle, which I focus a lot on vector 1. So let's do a recollection, which is method 2. Require you to use the vector triangle that I touched on vector 1. So recall, in vector 1 we learned this triangle. Okay, this A, this B, and O is here. We are talking about angle between A and B. So to find the distance here, essentially A cross B over modulus B. Okay, and to find the distance here, is essentially finding A dot B over modulus B. Okay, and we learn how to trigger our memory by looking at the angle between A and B. If you are going to find the opposite, we're going to link to sine, sine links to cross. If you're going to find the adjacent links to cosine, cosine links to dot product. Okay, all this I focus a lot on vector 1. Okay, we're going to use this to help me solve for shortest distance from a point to a line. Okay, so if I can redraw out a point here, which is 2, 2, and 4. Okay, my line direction, r equal to minus 1, 1, and 2 plus lambda 1, 2, 2. Lambda is real number. I can recreate out the vector equation of a line by letting a point A be here. Okay, this point A can essentially be using the point in your vector equation of a line, which is minus 1 and 2. Okay, deriving from this point in your vector equation of a line. Okay, what I'm going to do next is I'm going to link A and P together to form something like that, and essentially creating the vector triangle over here. Okay, very, very similar to my vector triangle that we learned in our first part. Okay, so if I can quickly show you again, okay, by creating this vector triangle, we can find the distance over here. Okay, the angle between AP and your direction is there. So we are actually finding the opposite. Opposite links to sine, sine links to cross. So the shortest distance essentially is this formula over here. Modulus of AP cross with my direction over modulus of direction. Okay, so what I'm going to do is I'm going to quickly find my AP over here first. So AP will be equal to OP minus OA, which is equal to 2, 2, and 4 minus away minus 1, 1, and 2, which will give me 3, 1, and 2. So over here, the shortest distance, which is AP cross with my direction over modulus of direction, will be 3, 1, and 2 cross with 1, 2, and 2 over modulus of 1, 2, and 2. Okay, if you can quickly cross it out, you should derive as this Cover the top row, take AD minus BC will be 2 minus 4, minus away 6 minus 2, and 6 minus 1. Over root 9, okay, which is 1 square plus 2 square plus 2 square. Okay, you should derive as minus 2 minus 4 and 5 over root 9. Okay, further simplify, you will get root 45 over root 9, which is essentially the same as what you use your method 1 to derive root 5 units. Okay, so essentially you should see that method 2 is a lot simpler compared to method 1, because method 1 requires you to find the full perpendicular. So by finding full perpendicular, once you are done finding full perpendicular, most of the students have already moved on if they actually use method 2. So do note that method 2 is very important in terms of time saving and a lot quicker if you just want to find the distance from a point to a line. Okay, so we're going to run back to the example over here. Okay, using the same point and same line as the previous example you did. Okay, same thing, okay, as how I actually did over here. Are you going to use the full perpendicular? Try using method 1 to determine the distance. Once you've done that, try using method 2, which is the trigo triangle that we touched on. Both of the method, you should derive the same answer. So make sure your answer is the same, then you know that you are correct. If your answer is different, make sure you go and check and ensure to try to spot a mistake to which one is correct and which one is wrong.